you can push it up to a release stream where you might do aggressive testing on installers, where you might do additional testing on performance and scalability. All the while, each time that a defect or a failure is detected in one of the streams, you have the ability to do two things. One, you have the ability to revert those changes so that you have restabilized the code, you've brought it back to a known good state. Again, in AccuRev, that's I almost want to say it's trivial to do. It's very, very simple to do that. You don't have to hunt around for individual files. If you're using change packages, you simply revert the change package and the change is gone. You can automate that sort of reverting so that, for example, if a failure occurs, you want to be able to automatically detect that failure, report it to someone, perhaps via email or some sort of web dashboard, and then have the system automatically back that change out atomically so that the system is in a known good state. The idea here is you can set up any hierarchy that you want that is meaningful to your process without being constrained in any way by the tool. All of this leads me to what's my final slide, and then this will be a good introduction to Anuja's presentation and the Coverity portion of the webinar, which is just metrics and process improvement in general. I have a rule of thumb. It comes, from my background, which is, in the hard sciences, physicist by nature, by training, which is that an unmeasured process is no process at all. If you're not measuring the process by which you're building software or building automobiles or building space shuttles, then you really don't have much of a process. Without measuring the process, it's somewhere between difficult and impossible to answer questions like, how do we improve the process? How are we doing on the process? How are things going? Is the project on time? Is it late? You need some sort of measurement in order to answer those basic questions. So short of saying, measure everything and sort it out later, I think there's always an opportunity to come up with some basic measurements. And once you've made some use of those basic measurements, to introduce some additional measures and some additional analysis of your code to ultimately improve quality. One of the basic metrics that is often overlooked is a simple thing like defect count per module, where the defect count is a reliable count. Now, those of you in the audience who do not like defect counts, and there's always a 50-50 split. It's like putting an underscore character in front of the names. Is half the namespace will not like defect counts and the other half will. The reason why I think it's an interesting measure and why you can make use of it is if you have, and everybody has one or two of these people in their company, people who always find the big, fat, juicy bugs. Those are the people that you want testing that brand new module, the people who really understand how to stress a piece of code and exercise it. And that's a practice that we use here and I've used at other companies, which is you make sure that you're running all of your regression tests and that, at the end of the day, you give it to somebody who really understands how to hammer on code. So the defect count per module is a pretty good insight into whether there's a problem area. For example, if you had 5 modules in your code and you watched for a week all of the defects that came in, and you noticed that there was a spike in the defects in module number 4, let's say, assuming that you trusted the people who were building those defects, who were actually doing that testing, you might say that there's a problem in module number 4. It seems to be showing a lot of defects. We believe our testers are not doing blue sky testing. They're doing real reliable testing. That's a pretty good count. Beyond simple metrics like that, you can really do a lot of sophisticated metrics. I won't go into a lot of them here because I want to make sure that everybody is attentive to the Coverity portion of the webinar where we talk about static analysis. But there's a lot of ways that you can introduce automated metric gathering into the process to make sure that you're getting some numerical insight into your process. At the project level, for those of you who are managers, project managers, or engineering managers out there, one of the important metrics that has come out of the Agile and Scrum world is the so-called velocity metric. Really a measure of how fast a team is able to build features. The good thing about this is that if you measure it over a couple of iterations of your project, and even better, if you measure it over several projects where you've been doing this process, you actually get to improve the predictability of your releases. Developers tend, in a given period of time, to be fairly reliable in their ability to deliver code, barring extraneous circumstances. If you measure this over a while, you get to determine with pretty good accuracy, with a given team, how long is it going to take to burn down to the point where we have zero feature work left to do, zero defects left to fix. Well, with that, I want to thank you on behalf of AccuRev, and I want to turn the webinar over to Anuj, who's going to talk about a similar topic from the perspective of using static analysis to help in the continuous integration environment and improve quality. And over to you, Anuj.
Okay. Thank you, Matt. Today I'm going to talk to you about a solution suite that allows you to build high-integrity software, reliable, secure, and performing as expected without fail. So let's start with the vision of how the software development world should be. You are continuously delivering high-integrity software on time and on budget. The software you produce performs as expected. That means it successfully meets the business needs and users' expectations. And managers are able to work effectively with the resources they have. They can accurately measure the efficiency of their teams and prioritize the resources where they are needed the most. So the key points are that you want predictability and efficiency in your software development lifecycle. This survey bears out many of the changes that we have discussed in the previous slide. And in today's very high-paced and complex development environment, it's harder than ever to deliver the high-quality code that meets the business needs and customer expectations. Obviously, the rate of change is problematic. You have a lot of applications being put into production weekly or monthly. Some websites even have daily updates. The complexity of their code and their environments is increasing. 72% of the people surveyed said their debugging process is problematic. And the number of critical defects is also increasing. 31% had 26 or more critical defects per year. Obviously, these require patches, and you're trying to get your product out to market faster. So what do the people on your team need that are trying to develop high-integrity software in this complex environment? Well, first and foremost, developers need to ensure that their code is defect-free and ready for check-in. Architects want to proactively ensure that the code conforms to their intended architecture, and managers and executives want to rapidly assess the code quality, complexity, and risk of their development organization. Let's go through a typical software development process. We design, develop, and deliver. So in general terms, this is the process for delivering software. Throughout that process, there are a number of different activities that are happening. You want to assess, architect, develop, build, test, deploy, etc. And we understand that you use a number of tools for all these phases. You have JDKs, you have source code management tools, and change management tools, such as AccuRev, which Matt talked about. You have unit testing, profiling, and also production monitoring. Coverity offers static analysis, architectural analysis, and dynamic analysis that development teams and QA teams can use to ensure software integrity and quality. On top of these tools, we have added a software readiness capability that really allows managers to assess the overall quality and risk for each code base and determine if they're ready to ship. Coverity Prevent offers these three key capabilities. Unmatched accuracy, so out of the box, Prevent features the lowest false positive rate in static code analysis.